Hello everyone, welcome to this problem solving session. Let us try to solve this one first. It talks about a 2 kilogram package. So this package right here, this package of tamales slides along a floor with speed v equals to 4 meters per second. So it's going with v1 speed. It then runs into and compresses a spring. So there is the spring and it compresses it by some amount. But notice, as soon as the object made contact with the spring, then the frictionless part ends and the part with friction starts. Its path to the initially relaxed spring is frictionless, but as it compresses the spring, a kinetic friction force, so it's very important, kinetic frictional force from the floor of magnitude 15 Newton acts on the package. Okay, so they are telling us the frictional force itself, not the friction coefficient or anything. It's just the frictional force directly, which is given to be 15 Newton, acts on the package. If K, the spring constant, is 10,000 Newton per meter, but what distance d the spring compressed when the package stops. So it's an interesting problem, but it should be an easy one. So what happens is, if we think in terms of energy, then initially the whole system, considering it to be isolated from the rest of its environment, the energy that is stored in the system is just the energy due to the kinetic due to the motion of this package. So that means the kinetic energy. So we have the energy, right, equals, so energy 1 equals, what do we have? We have half mv1 squared. Okay, so then what? Then we have the energy at the second position, the mechanical energy at the second position, to be so this is when the package compresses the spring, so that is given by half k d squared. So this is by the time when the spring stops, spring and the package stops. Okay, and then the difference, so these two are mechanical energies. So mechanical energies, I could have written E mech 1 and E mech 2 following the tradition of the book, but let's just do ourselves a favor and use the shorthand. So the difference in the mechanical energy, right, should be equal to the work done, and that work is done by the friction force, which acts in the opposite direction of the velocity of the package, and that is the friction force, dotted with d, the displacement, but they are just in the opposite direction of each other, or they are working in the same dimension. So since they are in the opposite direction, we have friction force Fr times d times cosine of 180 degree, which is -1. So we have minus F friction times d. Alright, so then we proceed as follows. So the change in the mechanical energy is E2 minus E1, which is equal to minus friction, the work due to friction, excuse me, so I should write F friction times d, and E1, right, my E1 equals E2 plus the work due to the friction, excuse me. So what does it entail in? It entails in the following expression, we have E1, so half m v1 squared, E2, so that is half k d squared, and then what do we have? We have the work due to friction, so that is given by F friction d. Now if we simplify this, we find the following. We have d squared, and so I'm dividing everyone by k and multiplying everything by 2. So I have d squared plus F friction, so this should be friction, divided by k multiplied by 2 times d. And then bring this to the other side, so minus, if you multiply it by 2, the half goes away, divided by k, so m divided by k times v1 squared. And this whole expression is equal to 0, so in terms of d, this is a quadratic equation which is easy to solve. So we know that d will be equal to negative 2fr divided by k times so plus minus square root, then we have 2 square root before 4 times friction force divided by k squared, friction force squared above, and then we have plus 4 times m divided by k v1 squared divided by 2. So if we could plug in the values, what do we find? We find negative, so the friction force, the magnitude of the friction force was 15 Newton, so we have 2 times 15, which is 30. 30 Newton divided by k is 10,000, and we have Newton per meter, so Newton divided by meter, okay, plus minus square root 4 times, so this whole thing squared, right? So we have 900 Newton squared divided by 10 to the power 8 Newton squared per meter squared. Okay, then plus, then 4 times the mass was 2 kilograms, so we have 8 kilogram. The velocity was 4 meter per second, if I remember correctly, so that's 16, and this is kilogram, so let me make some room. We have kilogram, and then for v squared we have meter squared per second squared, whole divided by k is simply 10,000. So I think this is a good place to use our calculator, with the square root, of course. Yeah, so let us plug in these values into a calculator and let's see what do I find. So this whole thing, I have inserted it into a calculator, gives 0.11 meter. So I suggest you check the units, and I believe you'll agree with this answer as well. So let's move on to the next one.